through number 4, which is a gain on charge. This is very nice. Anyway, there's a lot of marks to just get. So let's see what this one is saying. Air can act both as an insulator and a conductor. Consider reaching for a metal doorknob. Yes, air can act both as an insulator and a conductor. You know when air is a conductor? When lightning is coming down from the clouds, because lightning is charge that was in the clouds and then it is jumping all the way from the sky to the ground. And that is when it's a conductor. It takes a whole lot though. So air is normally an insulator, but when you put it under the right conditions, it can become a conductor if you put enough stress on it. You know what I mean? So let's talk about this. It's saying air can act both. Yes, true. Consider reaching for a metal doorknob after scuffing your feet over a carpet. So you have scuffed your feet over a carpet. What does it make you? It makes you charged because you've charged yourself by friction. You've been rubbing against the carpet, my friend, and now you are charged by friction. So you are a charged body. Now, as your hand approaches the doorknob, which is probably neutral, right? A neutral body or whatever, if it's positive or whatever, a spark jumps between your hand and the knob. So if a spark is jumping, that means the knob is either neutral or positive, and a spark is going to jump from your hand to the knob. That means that jump means it's going to move through air. Air is going to conduct, right? Explain how air acts both as an insulator and conductor in this situation. No problem. So we can just start by saying that dry air or air is a very poor conductor. You can say dry air is normally, or you can just say air. Whether dry air or air, you can just say air because they've said air. Air is normally an insulator. Okay, air is normally an insulator. Why? Because it doesn't have. You can say as it does not have free electrons or mobile charge carriers, or you can say mobile charged particles or charge carriers, mobile charged particles to carry a current. So it's an insulator, okay? Or you can say it just doesn't have or mobile charged particles, as it does not have free electrons or mobile charged particles, right? It doesn't have those, okay? So under normal conditions, air is an insulator, okay? And this is what makes it be an insulator. Now, what happens is, you can now come in and say, when you scuff your feet over a carpet, I have to write this in straight points. I have to be precise. So I'm trying my best, okay? You build up static charge on your body. When you rub your feet over a carpet, okay, you build up static charge, or you can say you build a static charge on your body, okay? Yeah, you can put here, your body becomes negatively charged. You can put this in brackets. Negatively charged due to friction. So yes, your body becomes negatively charged due to friction, okay? So now what happens is, as your charged hand, you can say, as your charged hand approaches, or we can say your charged hand ionizes the air around the knob. So you can say your charged hand ionizes. When we say it ionizes, you know what happens? you have an air molecule here. So air is like they are molecules, right? Some gas molecules together, and they have positive, they have charge, they have when it's a molecule, there's electrons inside there, and some, of course, the protons will be in the nucleus and whatever. So what happens is when you bring your charged hand, it's going to knock off electrons out of there, and these electrons will fall into the air, and they'll leave the air molecules being positive ions like this, and there'll be some electrons flying in the air, and the air now becomes charged, and it will become a conductor temporarily. Okay, and that is what will help then the charge on your hand to fly out to the knob. Okay, so you can now say your charged hand ionizes the air. It ionizes the air molecules. Okay, the air molecules around the doorknob, around the doorknob, and can let me say here, and this creates free electrons and positive ions. Okay, this is what you can, and this is what turns air into a temporary conductor. You can now just put to say, turning air into a temporary conductor. Okay, temporary conductor. I hope I've said everything here. Let me try to reduce the size of everything here so that it fits. Let me do it again. I want to reduce the size of everything which I've written so that it fits in here. Great job. Turning air into a temporary conductor. So what happens? Air is normally an insulator, right? Because it doesn't have mobile charge particles. But when you scuff your feet over a carpet, you build up static charge on your body due to friction, okay? Now, your charged hand ionizes the air molecules around the doorknob. And what does it do? It creates free electrons in the air. And the air now becomes a temporary conductor, okay? And you can now talk about a spark. The spark now jumping across your, or discharging from your hand, okay? Turning air into a temporary conductor. And you can now say a spark jumps across the hand and jumps across the space between the hand and the knob, and it discharges your hand, okay? So you can now talk about the spark now jumping across and discharging your hand. But you've already said everything. This is just now us wanting to add another point to say the spark then jumps across the air, discharging your hand, and you are done. Okay, discharging your hand. I've said a whole lot here. So air is normally an insulator. That's an important. Why? Because it doesn't have free electrons or mobile charge carriers. Now what happens is when you scuff your feet against the carpet, you're going to charge your body or build up static charge used by friction. Okay, then what then happens is your charged hand is going to then ionize the air molecules around the doorknob. To ionize, it means it splits them, right? Remember, it was air, it was a molecule, which means the negative and positive were stuck together, but it's going to split them. Then electrons will be now around and positively charged particles will be around, and all these things can move with the charge that is in your body. So what will happen is the charge that is in your body will then jump into the air, because air now has free charged particles. These charged particles are free to move. So that means air is now a conductor because it has charged particles that are free to move. So we say now that the charge on your body now jumps across the air, okay, to the doorknob, discharging your hand. This is what happens, okay? This is the final solution, and you'd be done. Well done for being so precise. We go on. See you in the next one.